Hello and welcome to this video tutorial on how to solve the first shellcode exercise called Baby Windows Shellcode Level 0. So let's start off by taking a look at the source code for this challenge. As you can see here, the standard input, standard output and standard error are unbuffered. This will just make it easier for you to interact with the challenge. Then you can see here that all mitigations have been disabled. And then we have the vuln function here, which is called inside of main. And the vuln function contains a buffer of x100 bytes, and it's calling virtual protect on that buffer with the size of x100, meaning that this buffer is going to be executable memory, as you can see here, page execute read write. And then it's going to take some input from the user, and it's going to read hex 300 bytes from standard in. This means that there is clearly a buffer overflow here, since we are reading hex 300 bytes into a buffer size x100. So now I'm going to show you the exploit script for this challenge, and I'm going to show you a little caveat that we're going to have to fix together. So I'm using the setup as I've shown in the other videos, where I start a challenge and then I call debugging using the input function in Python, and then I read my shellcode.bin from the same folder that the exploit script is in, and then I send a shellcode. I send the shellcode and then some padding of x100 bytes, and then we pad a little bit more with 8 bytes here, so we overwrite the RPP with B's, and then we put the address of the start of our input buffer right here, because then when the return instruction is called and we've overridden the save return pointer, this will be popped right into our IP, and we will start executing our shellcode. And then I just padded it with some knobs here just to make sure. Also to make it easier to see where I was in the payload. Then we're going to take a look at the shellcode here, which I've also used in the other video to introduce you how to shellcode on Windows. And as you can see here, it's now saying calc, but actually we would like to say cmd here instead, because we want to pop a shell on this machine. And this address right here, even though this is what we're going to have to fix, because even though the binary has all mitigations disabled, every time you restart your computer, the base address of kernel32DLL will automatically change, and therefore we have to change this every time we restart our PC. So then for this one, I also went through this in the shellcoding, introduction to shellcoding, and this is where we load the relative address of this string right here, and that's really neat because then you don't have to put it in your exploit script itself or anything, or calculate manually. You can just use this command right here. So now we need to figure out what the actual offset of winexec is, since this has changed since the last time I ran my operating system. So what we're going to do is we have our Python environment started, and we're going to say python xbl.py like this. It's just going to take some time to start debugging. I'm going to open x64 debug, alt A, and then we're going to press enter here on the binary. Let's look at our breakpoints. Yep, they have been saved. And go into symbols here, and just let's take a look at inside the vuln function. Yep, we have saved it here. And also what we can do now is we should definitely go to symbols again. We can see the base address of kernel32DLL here. So we'll say copy base, and then we can go back into this one right here, and we should put it in here. No, sorry, that's not supposed to be the base address, my mistake. We have to get the address of winexec. So type winexec here, and then copy this right here, like this. And now we need to just terminate this session and reassemble this shellcode, because now we have changed it. So what I'm going to do is go back into x64 debug, Control Alt F2 to terminate or to detach, and then we can go back here and just Control C, and we need to reassemble our assembly payload. I'm just going to say an estimate. Yep, and the command has already been saved here. So now we can run our xbuilder.py, and I still want to attach the debugger to just show you a little bit about what's going on. Mistake this, and we go in here, Alt A, Enter, and then we just go back here and press Enter to make it continue the execution of the exploit script. Go back into our debugger, and now we can see we have hit the breakpoint and up right here. And the fgets here, as you can see, now we have the RAX here, which is pointing to FD14 FDE0, FDE0, that's right here. And this is actually our shellcode right here. As you can see, there are a lot of A's here with the hex 41. And that's because fget's return value is the pointer to the buffer or memory where it is reading into. So that's why we can confirm this right here. So what we want to do now is press F8 to step down into the red here, like this, and we can see that red have been overridden with 14 FDE0, which is what we put in our exploit script, which I can show you right here. So override red address with the start of our shellcode. So now if we use the F7 button to step into, we'll see that we actually hit our shellcode right here. Now we're executing inside of the buffer because it's executable. And if we step down here to call RAX, we can see that RAX contains the address WinExec, and RCX holds the pointer to a string command, like CMD here. And we have RDX with a value of 1, which is show normal in the arguments to WinExec. So when I use F8 here and step over, what will happen is we will reach create process A, and if I press F8 again, what we can do is we can go back in here and wait a minute, let's just press F9 to continue. Mistake, just a moment. Yeah, so it didn't work with the debugger attached, I'm sorry, but when we run it here in the in the terminal itself, you can see that we are no longer in our Python environment, and that's actually because we've just spawned a cmd.exe here. So our exploit worked, and I can show you in just a moment with the calculator as well. So for example, if I say who am I, you can see that clinical comes up, and if I press Ctrl C, we'll exit the cmd.exe and get back into our original PowerShell shell. So just for convenience sake, to prove that it works, I'll just write calc here, and then we'll just reassemble our shellcode script, and you'll see there that it works. So thank you very much for watching.